All right, Jessica, I'm not sure why you are here. You just want to have a look at the questions again. If it is, that's fine. Just feel free to ask any questions if it is not clear. Right. Uh, for this lab assignment, you'll need to answer. Okay, so workshop will be run face-to-face on campus from 2 p.m. This is just for the lab assignment. For those who could not attend the lab. Oh, that's fine. You can stay if you want to, but if you don't want to, that's fine. Feel free to leave. Right. Anyway, so you'll need to answer the questions you have and try to answer all the pre-lab quiz questions before you start, and then later on, please go back to those questions, and then you should be able to find the correct answers, right? So we have 5 multiple choice questions, and please spend some time because it's a multiple choice question. They're all multiple choice questions, and then the quiz you're gonna have next week will be really similar to the questions you are seeing over here. Okay, so part A, first part. In this one, you will need to use your imagination, unfortunately. And when you look at the tasks you will need to do, you should be able to answer easily. For the first one, you are putting salt in a test tube, and then you are adding water. So you should be able to answer this question without any problem. It'll dissolve, right? Dissolve. And next one, it should be pretty much the same activity. You're putting calcium hydroxide, and then you are adding water. So based on the solubility rule, you will see it'll dissolving. But as a matter of fact, if you do lab activity, if you put this one with not enough water, you will see it is not dissolving, because it is also based on the rule. It is soluble. It is not highly soluble. So to dissolve a certain amount, you will need to add a lot of water. And then next one is something you did in the previous lab. Remember the filtrate? You had chlorine. So you are adding a solution containing chlorine. You are adding silver nitrate. So although they are all aqueous, both are aqueous, once silver is in contact with chlorine, it will form solid plus potassium nitrate, which is aqueous. So you'll see a sort of precipitation reaction. So as soon as you add silver nitrate, you'll see the solution turning into a bit of, say, murky white solution, and then eventually it will precipitate. Right, and so this one, right? This part is all about precipitation reaction. So depending on the solubility, you will see some of them will precipitate, some of them will stay as a clear mixed solution mixture. So the one in red, they are all created precipitate, which means mixture of these one making into a solid compound. That is why you need to write red ion equation. For example, the one in red, number 1. So you mix with calcium, which is over here, and with sulfate anion. So although they started with aqueous solutions, eventually you make solid. So when it comes to say that ion equation, you don't really have to worry about spectators. Hello, Bettina. At least one of you guys are here. Right, so let me know if you have any questions. I already studied, so I'm not sure which part you missed, but the main ones you should be able to follow. It is not gonna be super complicated. And so as a start, you will need to write the starting cations and anions and then make it into one compound because you make a solid product, right? So we have an example of the first one, and the next one should be number 2. It's calcium carbonate, which is just a chalk powder. So you start with Ca2 plus with, let me just make it a bit smaller. There you go. Making calcium carbonate. So one of the starting material is Ca plus, and the other one is carbonate. So you start with this one, and then your product should be CaCO3. And then you gotta specify it is in solid. And you just need to do everything in red like that. So you gotta be careful about charge when it comes to, say, for example, number 4. Let me just get rid of this one, arrow. Number 4. Okay. Number 4, and then number 5, and number 9, for example. So I'll just start writing over here instead of writing it onto the each number because space is not enough. So for example, let's look at number 4, silver sulfate. So you started with Ag plus, which is aqueous, and then you mix with sulfate anion, SO4 2 minus, which is aqueous, right? So when you see a precipitate reaction, it has to be as a solid compound. So you gotta write as compound. And the issue is when you look at the charge over here, silver is only one positive charge, whilst the sulfate is negative 2 charge. So you gotta balance the charge. So the only way you can balance is not adding another charge because silver's charge is always positive 1. So instead, you start with 2 silver, right? So by doing this, you are balancing 2 charges over here, as well as 2 positive charges on silver, and then 2 negative charges on sulfate. So since it is charges balanced, you also need to balance the number of atoms. Since you started with 2 silver, you gotta have 2 silver over here as a subscript number. By doing this, everything can be balanced, including the number of atoms and charges as well. And you do the same for silver carbonate, so it should be quite straightforward now, right? So instead of sulfate, I'll put carbonate, CO3 2 minus. So same problem here. We have 2 negative charges here. We have 1 positive charge. So if you start with 2 silver, it should be aqueous, making silver carbonate in solid. So it should be like Ag2 CO3, which is in solid, right? And lead sulfate, another example is not lead sulfate. Lead sulfate is already balanced. I'm looking at number 7. So Pb 2 plus, which is aqueous, plus sulfate. So by mixing these two, you'll create really bright yellow, which we used to use as a food additive, like in medieval ages. We used to put this one in milk to make it look like a creamy milk. It was a silly idea, but we didn't know silver will damage our nervous system. Anyway, so when you look at these two, charges are already balanced, so you just need to combine these two into one single solid compound. So it should be PbSO4 solid. So the other ones should be quite straightforward, except silver iodide. And you will need to do the same as silver, but instead of balancing the cations, so you always start with whatever you added. Since it created precipitate, it should be in solid. So you just need to combine. But before you finalize everything, you need to have a look at the charge. So +2 charge here, -1 charge. So it has to be 2 here. Right? By doing this, you are balancing the charge to positive and then to negative here. And then once you write your compound, you also need to balance the number of atoms by putting 2 over here. And then you also need to state its physical state, right? So I will leave our remaining ones, and it should be quite straightforward. And let's move on to the trickiest one. It is quite tricky because we really haven't covered steps doing balancing redox equations in our workshop or in the lecture. We did some, but I guess it is not enough. Okay, so in this experiment section, you also need to mix A and B, and then you will need to see the changes. And if you see changes in appearance, it means something was happening. So what happening over here was a redox reaction, and then you'll see this one, number 1, 2, and then number 3 working, and the other one's not working. And when you look at Fe3 plus, since it is a redox equation, something has to be oxidized, whilst the other one has to be reduced. So in this case, iron should be oxidized, but when you look at this one over here, Fe3 plus, so it is fully oxidized. Because of that, there's nothing to be oxidized, and this is why you expect to see nothing on here, whilst Fe can be oxidized with acid or without acid. And then when it comes to bromide, will be oxidized at the presence of acid, which is H plus. And without acid, the reactivity is not strong enough, so it's not going to be happening. And because of that, these 3 will work, and then you'll need to balance these ones. So to start with, so when it comes to number 1, it is Fe, which is solid, plus permanganate, HS, making it into something else. So to balance redox equations, you can start from whatever you have over here, like previous experiment. But if you do it, you will likely make a lot of mistakes. It applies not only to you guys, but also to me. That is why we always do balancing redox equation using 2 half equations. So when you look at this one, it is split into separate halves. So one of them is reduced, the other one is oxidized. So we balance each one by one, and then once everything is balanced, you will need to combine them into one full redox equation. So the steps for doing redox will be available in your lecture note, and have a look at the lecture note and try to follow the steps. But I will quickly do number 1 and 2, and then a little bit of number 3. And once you know how to do it, number 3 will be quite straightforward, right? Okay, so let's balance these 2 one by one. So let's look at the first one, permanganate. So I'll start somewhere in the middle. Mn or for minus goes into Mn2 plus. So this is the half equation, and I expect you not to know, because this is something you really haven't learned, and normally these ones will be given. Anyway, so when it comes to balancing redox equation, you start from the heaviest element to lightest element, except oxygen and hydrogen. So when you look at the number of manganese, they're all balanced, one on each side. So it is balanced. So now we need to move on to oxygen. And to balance oxygen, you need to use water. Since we have 4 oxygen on the left-hand side, you have to have 4 water to balance the oxygen here. So now we have 4 oxygen on the left-hand side and then 4 oxygen on the right-hand side. So by using water, we now have excess hydrogen on the right-hand side, which are now 8 hydrogen. So to balance the hydrogen, you'll need to use proton or H+, which is acid, right? So when you look at the number of hydrogen on the right-hand side, you have 8 hydrogen. Because of that, you will need to put 8 proton or 8 acid to balance the number of hydrogen, right? So now everything is balanced when it comes to number of atoms or elements. Now you need to, lastly, you need to balance the charges on the reactants and product. So let's have a look at overall charge over here. So charge over here, it has got a positive 1 charge, and then you have 8 of them. So charge over here should be plus 8, and then charge over here from permanganate is only minus 1. So overall charge should be plus 7. And then when you look at the ones on the right-hand side, over here you have plus 2 charge, and then you have 4 neutral water. Water has no charge, so charge should be 0. Overall charge should be plus 2. Right, so now we need to make these numbers equal using electrons. Electrons should be like that. Right, so electrons charge is always -1. Because of that, you can reduce the amount of charge, but you cannot increase the amount of charge. So you need to add electron where the charge is greater. So since over here charge is plus 7, you'll need to add electrons. So to make these numbers equal, you'll need to take away 5 charges, right? So to do this, you'll need to add 5 electrons, right? Now everything is balanced, including the charge. So 1/2 is balanced. Now let's have a look at the other half. So let me use different color on this one. Now let's have a look at iron here. So you do the same. You start from iron goes into Fe2+. So it'll be quite straightforward because we only have 1 iron atom as a start, and then ended with 1 iron atom. So atoms already balanced, so you don't have to worry about using water for this one. Now you need to balance the charge. So charge over here is none. Charge over here is plus 2. So because of that, when you take away 2, you will have equal charge. So you need to add 2 electrons, right? So now 2 halves are balanced. So you need to write everything. It's a full redox equation. And before you put them into one single redox equation, you gotta be careful. because the number of electrons on both sides are not the same. Since we cannot leave any free electrons wandering around, because electrons don't wander around, once they disappear from somewhere, has to be go somewhere else. You gotta integrate the number of electrons. So the easiest way should be find the integers from each side, and then you multiply everything using the integers. So the easiest way will be look at the number of electrons on both sides. So you have 5 electrons, 2 electrons, right? So when you take this number to here and then multiply by 5, you will have 10 electrons on the right-hand side. When you look at the number of electrons on this side, using this number, when you times by 2, you will have 10 electrons on the on left-hand side. Right. So now using the integers, we will put everything into one redox equation. So it'll be 10 electrons on the left-hand side. So I'll just cancel this one because I just wrote it over here. Plus 16 protons. 8 times 2, 16. Plus 2 permanganate. And then from the other half, 5 Fe. 1 times by 5, right? Goes into 2 Mn2 plus 8 water plus 5 Fe2 plus 10 electrons. So when you look at the everything on the left-hand side and right-hand side, we do have a common terms, right? Electrons, which we cannot leave them on our final redox equation. So this will be the final answer. If you ended up with a different number of electrons, you made a mistake somewhere. So you need to go back and then you do the proper integration. So always remember number of electrons from both half equations and use them as integers, right? By doing this, you should be able to cancel the electrons out. And the next one. So this one is Fe without acid. So it is basically our same process, but you will need to cancel this one out using base because it was without acid. So if you have a proton on the left-hand side, the answer is not going to be correct. So let me just use the original color. So since without acid, permanganate will turn into manganese oxide, solid manganese oxide. So it is a little bit different when it comes to balancing first half, but the process will be pretty much the same except one extra process. So we start from MnO4 minus goes into MnO2. So manganese, they're already balanced, right? So we don't have to worry about it. Now we need to balance oxygen using water. 4 oxygens and then 2 oxygens over here. So you need to add 2 water, making 4 oxygen in total. Now we need to look at the number of hydrogen. So we added the water, putting 4 extra hydrogen. So to balance the hydrogen, you need to add same amount of proton, right? So it appears to be balanced, but remember that it was without acid. But when you look at your equation, you suddenly see acid over here, right? So because of that, you need to cancel acid using same amount of base here on both sides. Now, when you look at this small reaction over here, when you look at this one, you have OH minus and H plus, so acid base reaction. When you mix acid and base, you will create water. Since we started from 4 of each, you will be ended up with making 4 water, right? So since this is now water, it is neutralized. Now it is not acidic, it is neutral. So now everything is fine, except charge and something else. Now we have extra water. You can even cancel this one out, leaving only 2 water, right? So let me just use a different color. So it should be, instead of this one, should be plus 2 water. Now you need to balance the charge. Hang on a sec, it looks really complicated. Let me just write it down again. So that one should be 2 water plus MnO4 minus goes into MnO2 plus 4 OH minus, right? So when you look at the charge, water has no charge, and then it has minus 1 charge, and it is neutral, and then it is minus 4 charge, right? Now you need to add electron on the left-hand side. So to make these ones equal, you need to have 3 electrons, right? Now first half is balanced, and then the other half should be quite straightforward. It should be exactly the same as the previous one. Fe2 plus 2 electrons, right? Now the most important part, you need to integrate using the number of electrons on both sides. So it should be over here times by 2 from the number of electrons on the other half. And then over here, it should be times by 3. And then you will need to write everything. So everything on the left-hand side goes onto left-hand side. Everything on the right-hand side goes onto right-hand side. So in the end, you should have 6 electrons on both sides, enabling you're canceling them, right? Leaving the number of reactants and the number of the product based on the integers. And I will leave these ones to you guys. And then lastly, so I'm not going to go through this one again because it is same process. It is the same as number 1, right? So you should be able to balance both number of atoms and then charges. And next one. So it is a little bit tricky because you need to pay attention on the number of bromine. So 1 bromide and then into bromine, right? So Br goes into Br2. So you need to balance the number of atoms. So over here, we have 2 bromine. Over here, we only have 1 Br. So to balance, you start with 2 here, right? And now the number of atoms are balanced. Both now are 2. You need to balance the charge. So over here, the charge is minus 2. Over here, charge is none. Because of that, you need to add 2 electrons. And then the other half should be MnO4 minus goes into Mn2 plus, and then you should have some amount of water. You will need to find out, and then over here you need to have proton, and they should have a specific number, and then over here you should have, say, specific number of electron. In the end, you need to do, so say the number over here is A times by A over here times by 2 here, because of the number of electrons from the other half is 2, right? By doing this, you should be able to combine into one redox equation. All right, the last one. Okay, so over here, so it is pretty much the same process as two previous experiments. You will need to write that equations on these ones. So let me just pull it up, or maybe shrink it because I cannot see what was on. There we go. So copper hydroxide and iron hydroxide, and then silver and plus copper, and then silver plus Fe2 plus, they all work, whilst the other one's not working. So these two, number 1 and 2, they are precipitation reaction. Precipitation for both. And then number 3 and 4, they are redox reaction. I'm not sure what's happening. All right. So these two are redox equation. And I think we have some, yeah, there we go. So the question asks, write the net ionic equations, right? So we have an example of copper hydroxide. And the second one was Fe2 plus or H minus. You always start with whatever working, and then you start with your two starting material, and then you need to balance if it's necessary. So over here, you need to balance the charge, right? Same as over here. You gotta have 2 hydroxide. So in the end, the answer is quite straightforward because we have an example of copper hydroxide. So number 2 will be quite straightforward. And then number 3 and 4, okay. So based on the table, you started with Ag plus, which is aqueous, plus copper metal, which is a solid. And I said it's a redox equation. I just gave you a say clue what was happening because you could not attend the lab. And next one, it should be pretty much the same process. So I think we put crystal ferric sulfate. Anyway, so since it's redox equation, one of them should be reduced, the other one should be oxidized. In this case, that one can be reduced, that one can be oxidized, right? So when silver cation is reduced, it will turn into solid silver. Then copper needs to be oxidized. But fundamentally, copper is a transition metal, and then the common oxidation state is 2+. Copper loses 2 electrons when they oxidize. Because of that, you need to balance the charge. So easiest way to balance the charge over here is +1, +2, right? So if you have 2 of them, charge will be balanced. So since you balance the charge using 2 silver, you should have 2 silver over here. Right? So in this case, this is reduced and this is oxidized. Reduced, then this is oxidized. Oxidized. Okay, so last one. So they are all oxidized, but based on the activity series, this will be much more reactive than this one. Because of that, silver is strong enough to steal electrons from Fe2 plus. So silver will be again reduced. And then, so this is something we really don't covered in Cabernet, but iron has mostly 5 oxidation states, but most common one is 2 different oxidation states. Iron can lose extra electron, forming Fe3+. Now, when you look at the number of atoms and charges, they all should be balanced. So +1, +2, and then no charge, +3. The overall charge on the left-hand side is +3, as well as the +3 charges on the right-hand side. And once it is done, that's it. And you'll need to go back to the this pre-lab quiz, and then you should be able to answer pretty much everything, right? Okay, so I will need to stop over here now because I need to go to the workshop theater. Hey, Bettina, do you have any questions? Right, looks like no. So if you have any questions, guys, please feel free to shoot me an email. Right, and then hopefully I can see you face to face for those who can attend the lab. If it's not, we should be able to see at some stage. Right, thank you.